Newton's law of cooling relates the rate at which a body cools to the difference in temperature between the body and the environment into which it is introduced. The formula, this is Newton's law of cooling equation, means this. This variable is going to be replaced by the object's temperature, whatever the object might be. This variable is going to be replaced by the temperature of the environment the object's going to be put in. T is time. In order to use this formula, we first need to use the information they give us in the problem to find C and B. Once we find C and B, we could answer the question. So use Newton's law of cooling to solve the following problem. A cup of coffee has cooled from 100 degrees to 60 degrees after 10 minutes in the room at 24 degrees. So the original temperature, in other words, at time equals 0, that means the original, was 100 degrees. So the coffee was 100 degrees when the clock started ticking. Then 10 minutes went by and 100 degrees went down to 60 degrees after 10 minutes. The 24 degrees here is the environment's temperature. So at t equals 0, if we let this t equal 0, then we would let this equal 100, because at t equals 0, the temperature of the coffee was 100 degrees. So this is the object. In this case, the object is coffee. The t sub 0 is going to get to 24, and that's the constant temperature of the environment. So this won't change. So with that information, we should start finding C and B. So this is the environment's temperature, and in this case, the room temperature. At time equals 0, the temperature of the coffee is 100 degrees. So at t equals 0, the coffee is 100 degrees, original temperature of the coffee. So we could plug in the 100 for this variable. For the t sub 0, we plug in the 24. So object's temperature, environment's temperature. And this is at t equals 0 at the beginning. Notice the b is not there anymore because b to the 0 is 1, and 1 times c is c. Anything to the 0 is always 1. So this portion becomes a 1. 1 times c is c. So this is what we have. Just move the 24 over to the other side and we know what the c is, and then put it where it goes. This is where the c goes. We found out what the c is, so now we could give it its value. It's 76. We just need to find the b. To find the b, we continue using the information they gave us. They said that after 10 minutes, the temperature of the object, in this case the coffee, became 60 degrees. So in 10 minutes, that's t equals 10, the object's temperature became 60 degrees. The 24 doesn't change, that's the environment's temperature. The 76 we already found. So the only variable that we need to solve for is b. So we need to move all these numbers away from the b, and we'll find out what the b is. So you move them one by one. So you move the 24 over by subtracting 24. So it's 60 minus 24 is 36. So this, after the 24 goes over, becomes this. Now we need to get this 76 over to the other side, so we divide both sides by a 76. That cancels 2, 1. And we have this. Now, put parentheses here and highlight that if you don't have a power, it's a 1. But then divide both sides by a 10. So this one will be 1 over 10. And over here, 10 over 10 is 1. So that leaves you the b. So key this in, and this is what you get for the b. Now put the b back in the equation. Now that you have found C and B, you could answer the question. Use this formula to answer the question. And what was the question? How long, how long will it take to cool to 30 degrees? So how long is a time question? In other words, we're solving for T, and we would like to know how long will it take for the coffee to reach 30 degrees. So remember, f of t is the object, the coffee. So start moving the numbers over. So we'll move the 24 over by subtracting the 24 on this side. That cancels here. 30 minus 24 is 6. Now move the 76 over by dividing both sides by a 76. That cancels the 76 to a 1 here. And now, right here, we would have to remember, how do you bring a variable from the power position to the base position? How do you bring a variable down? You use logarithms. So we're going to take the log of both sides so we could bring this t down. So the next step is take the log of both sides. So we take the log, or you could use ln, it doesn't matter, you get the same answer at the end. So I take the log, the log of both sides. Now this enables me to use the property of logs that allows this power to come down here. Now that you have the power of t here, you could divide both sides by this number, cancel it from here. Just make sure you divide the other side by that number. So we have solved for t. Key this into the calculator. You could round. So this is about 34 minutes. It's going to take 34 minutes for the coffee temperature to become 30 degrees.